Good day, everyone. Today I'll be reporting two topics, which is transform data and create a code book. So first, let me introduce myself. I am Josephus Parajes from BSTA 3-1. So the first topic I will be reporting is transform data. It is optional. So transforming data is an optional step in the workflow. Researchers transform data as certain analysis techniques require this. It might help interpretation or might help meet the assumptions of techniques that will be discussed in subsequent chapters. So from the word itself transform, we'll be changing the data we collected to help us easily use the techniques that will be used in the further step of the study. So there are two types of data transformation. The first one is variable specification, and number two is the scale transformation. Number one, the variable specification. It involves transforming data to create new variables or to modify existing ones. The purpose of specification is to create variables that are consistent with the study objective. Recoding a continuous variable into a categorical variable is an example of simple specification. To further understand the variable specification, let me give you an example. So the first example is, if we have a variable that measures respondents' number of flights, indicating the number of flights per year, we could code those flights as flights below 5 as low, which is equal to 1, flights below 5 and 10, which is medium, and everything above 11 as high or is equal to 3. So as you can see, we like summarize or group or clustered the number of flights below 5 as low, and flights between 5 and 10 as medium or 2, and everything above 11 as high. So if we have data like 5, 4, 3, 1, 1, 5, so those flights will be belong as one group to low, and flights between 5 and 10 and so on. Just note that while there are situations that require coding, example, we might be asked to give advice based on different income groups where income is continuous, we should generally avoid recoding, because recoding a variable in such a way always results in a loss of information, since the newly created variable contains less detail than the original. So another example of risk specification is swapping the plurality of questions. If you have a variable measured on a 5-point Likert scale, which is 1 strongly agree, 2 agree, 3 undecided, 4 disagree, and 5 strongly disagree. We can change this to 5 strongly agree, 4 agree, 3 undecided, 2 as disagree, and 1 as strongly disagree. So as you can see, we just switch the polarity of the values so that 1 becomes 5 or 2 reverses with 4 and so on. So there are other types of variable specification. The first one is dummy variables or dummies itself. Creating a dummy variable is a special way of recording data. Dummy variable or simply dummies are binary variables that indicate if a certain trait is present or not. So we can use a dummy variable to indicate that advertising was used during a period. We can also use multiple dummies to capture categorical variables effects. So for the second one is constructs. So the creation of constructs is a frequently used type of variable specification. A construct is a concept that cannot be observed but can be measured by using multiple items, none of which relate perfectly to the construct. To compute a construct measure, you need to calculate the average or the sum of several related items. So for the last one, the index. We can create an index of sets variables. For example, we can create an index of information search activities, which is the sum of the information that customers require from promotional materials, the internet, and other searches. So this measure of information search activities is also referred to as a composite measure. But unlike a construct, the items in an index define the trait to be measured. So the second type of data transformation is scale transformation. So scale transformation involves changing the variable values to ensure comparability with other variables or to make the data suitable analysis. Different scales are often used to measure different variables. So for example, we may use a 5-point Likert scale for one set of variables and a 7-point Likert scale for a different set of variables in our survey. Owing to the difference in scaling, it would not be meaningful to make comparisons across any respondent's measurement scales. But these differences can be corrected by standardizing variables. So a popular way of standardizing data is for scaling this to have a mean of 0 and a variance of 1. This type of standardization is called z-standardization. Mathematically, standardized scores z sub I, also called as z-scores, can be obtained by subtracting the mean x bar or x sub I. And another one of scale transformation is by using range standardization. So range standardization or R sub I is another standardization technique which scales the data in a specific range. For example, standardizing a set of values to a range of 0 to 1 requires subtracting the minimum value of every observation, x sub I, and then dividing it by the range, which is the difference between the maximum and minimum value. So another type of scale transformation is log transformation. So a log transformation is another type of transformation that is commonly used if you have skewed data. Skewed data occur if you have a variable that is asymmetrically distributed and can be positive or negative. So log transformations are commonly used to transform data closer to a non-numeral distribution when the data are right skewed. For example, the data are non-negative. So taking a natural logarithm will influence the size of the coefficient related to the transform variable, but will not influence the values of its outcome. So the last type of scale transformation is aggregation. Aggregation is a special type of transformation. Aggregation means that we take variables measured at a lower level to a higher level. We can calculate the average satisfaction at the channel level. Aggregation only works from lower to higher levels and is useful if we want to compare groups at a higher level. So for the second topic, it is create a codebook, which is the essential details of the data collection. So so after all the variables have been organized and cleaned and some initials descriptive statistics have been calculated, we can create a codebook containing essential details of the data collection and data files to facilitate sharing. So this is the usual structure of a codebook. There are 5 parts, which is the introduction, questionnaires, description of variables, summary statistics, and data sets. So first, the introduction. The introduction discusses the goal of the data collection, why the data are useful, who participated, and how the data collection effort was conducted, like for mail, internet, face-to-face, questionnaires, interview, etc. So introduction is like the summary or the abstract of our research study in the codebook. So here we just summarize the data collection, why it is useful, and its goal. So for the second part is the questionnaire. So it is common practice to include copies of all the types of questionnaires used. Thus, if different questionnaires were used for different respondents, example, for French and Chinese respondents, a copy of each original questionnaire should be included. So this is very important because during the study we might be needing more data to collect. So that's why if we have the copy of the questionnaires in our code book, we can easily access and use the questionnaires for additional collection of data. So the third step or the third part is the description of variables. So this section includes a verbal description of each variable used. It is useful to provide the variable name as used in the data file, a description of what the variable is supposed to measure, and whether the measure has previously been used. You should also describe the measurement level. So this is like the glossary of a book. So each variable is defined or is its meaning, and also it's used in the study. So for the fourth one, the summary statistics. This section includes descriptive statistics of each variable. The average only for interval and ratio scale data. Minimum and maximum are often shown. In addition, the number of observations and usable observations, excluding observations with missing values, are included just like a histogram if applicable. So summary statistics, here we put the graphs, the data, the tables of our research. So mostly this is where our data is stored. Not particularly stored, but here is where it is explained or where it is been summarized by the researchers. For the last part of creating a codebook is the data sets. This last section includes the names of the data sets and sometimes the names of all the revisions of the used data sets. So codebooks sometimes include a file date to ensure that the right files are used. So this is data sets is basically where we put our data sets. So when we store them, this is like a file save in real life. So the data sets we use in our research, the data we collected, the data we observed, the data we our outcome as our data. This is where we store. So, conclusion, transforming data helps interpretation or might help meet the assumption of techniques that will be discussed in subsequent chapters. Creating a code book is an important step in the management of any data analysis project. The code book will serve as a reference for the clinical team. It will help newcomers to the project to rapidly have a flavor of what is at stake and will serve as a combination tool with the statistical unit. That ends my report. I thank you all for listening. Good day.